All right, so this is the next video in the series. We just covered oil, and so in this one I'd like to cover oil, shale, and sand, along with natural gas. These ones will both go a little quicker, so apologies for the last video that ran on a little bit, but I'll do a better job this time. And so oil, shale, and sand is extracting kerogen from solids, and so this is what it looks like. This is actually like sand, small bits and pieces of mineral material and rock material that have kerogen in them, and we can extract the kerogen from it and process it into oil. And so the extraction and the processing part is a little water and soil intensive. And so you see down here that it takes 1.8 metric tons of sand and shale. So this stuff right here, we have to extract 1.8 metric tons of that in order to get 1 barrel of oil, which is about 40 gallons or so. So it's very, very destructive to the land. This is going to be taken out of the land via strip mining, and so that can be devastating when you're processing just that much material to get such a small amount of oil. We've got oil shale in the United States, typically out west. However, with low oil prices, it can make this difficult to extract. The energy returned on energy invested is very low here, and so this is partly why the price of oil, of gasoline in the United States is so low right now. The OPEC countries, the ones that control the petroleum resources, the major petroleum resources, are trying to push oil, sands, and shale out of the market. For oil, sands, and shale to be economically viable, they need the price of crude oil to be about $90 per barrel, and currently it sits at $37. And so it's not very economically viable to be processing this stuff. And there's videos of T. Boone Pickens, a pretty famous oil baron in the United States, laughing at the process of removing oil, shale, and sands 30 years ago during peak oil because of how expensive it was. But now that the oil prices have hit this, right? They were here not that long ago, maybe 2 years ago. It's becoming more viable. Oil sands is very similar to oil shale. This is going to be extracted through strip mining, which results in major land damage. You also use a ton of water. So hot water is one of the things used to separate out the kerogen from the sand, and that's partly why we get this huge cost of energy to make it. The good news with it is it's very extensive in supply, and so there's a lot of this type of land out there. It's typically in remote areas like northwestern Canada or the forests of Venezuela. So not a lot of people live there, but economic or environmentally, it's pretty devastating. Natural gas. So the other side of this is natural gas. Typically, we're going to talk about methane with natural gas, but propane and ethane would also fit under this. Natural gas is estimated to last 60 to 120 years. There's a couple big players here, but we can also make our own natural gas through biogenic gas. And so this is what is in landfills. And so if you are looking at a landfill, typically there's going to be some sort of catchment underneath and some pipes coming off of it. They might work like so, or it could come up underneath it. But at any rate, it's produced down here in the bottom of the landfills as microorganisms are breaking down and decomposing the matter that's there in the landfill without oxygen. So anaerobic would be without oxygen. And so that has a methane release on it. And so it's thought that we could harvest this methane as biogenic gas and use it for fuel purposes in the future. Natural gas is a really great fuel for us to use because of all the fuels that we've got. So oil, coal, nuclear, it's very clean burning. It produces carbon dioxide, as would anything that you're burning would produce carbon dioxide. But there are no nitrogen containing compounds, no sulfur containing compounds that you find in oil and coal. So it's very clean in that you're not getting any of these other really nasty pollutants. Initially, we only used it in street lamps. Now we use it pretty commonly for heating and cooking. And transportation is also increasing. I know that there's a propane boat motor you can get. It's not a very high horsepower motor, but it runs off propane, which is pretty interesting. We transport it as liquefied natural gas. Now, for transportation, it's also pretty commonly used in public transportation. So you'll see a lot of buses around that are running on clean natural gas. So we transport as liquefied natural gas, and this would be a liquefied natural gas tanker truck here. And so these are super cooled, holding it in liquid form, which means you can get a lot more of it. It'd be a lot more dense and in liquid form on the ship and move it around. Conventionally, we can find it above crude oil reserves, and so if you remember back to the picture in crude oil, you could see the layer of natural gas on top. There's also unconventional, which are shale beds, typically, and so these are the ones that you hear about when people talk about fracking, and fracturing the shale is what it essentially stands for. And so there's rocks that have little pores in them in these shale beds, and those little pores are filled with this natural gas from the bacteria decomposing the stuff, the organic matter that made the shale millions of years ago. What we can do is we can pressurize, so we'll drill down to these shale beds and pressurize them with water and a lot of other different chemicals, and it'll actually crack the rock, right? You're literally breaking the rock, fracturing the rock into tiny little pieces. By doing that, you're releasing all the little tiny air bubbles in those rocks, and that natural gas is able to escape up through the pipe, and we can collect it and take it out. And so this is how we would extract natural gas. This is talking conventional up here, where we simply just open up that deposit by drilling down to it, and we let it flow out. A lot of the conventional ones have been depleted, which is why we get to the hydraulic fracturing or fracking, which I just described a little bit ago. This is the fracking process. And so we've got the injection well, which is drilled down through the ground, and here's our shale deposit. And so these little cracks here are where the methane and natural gas are able to flow back into the well. And so we've already injected the water and the other chemicals, and we've allowed that rock to break and transmit out its natural gas. The downside here with this is these wells are cased, all right, and you can kind of see it here, cased in concrete as they run through things like our aquifer right here. And you can get a lot of problems if this casement fails, and I think it's proven that casements will fail around 80% of the time in 15 years or something like that. And so a lot of them are failing, and if it does fail, what you end up having is you have natural gas leaking out into the water, and it'll dissolve in the water, which is a bad thing. We can't clean aquifers very well, and so once they get polluted with this natural gas, it becomes unsafe to drink for people, for animals, which can be a problem if you're doing this right around a town that relies on well water for this aquifer below. The other thing that happens with this is the water and mixture of chemicals you're using to fracture and dissolve and break up the rock down here has to be disposed of, and so typically those are going to be injected back into the ground, and they could be deposited as low as this layer down here, and it's kind of an out of sight, out of mind, but there's some really nasty chemicals mixed into this, and so if they're not disposed of properly, you could have another big problem on your hand. So some advantages, disadvantages to natural gas. We've got a lot of it left, especially when you factor in shale gas. The energy return on energy invested is very high, so you get a lot of energy out of fracking versus what you're putting into it. And as far as fossil fuels go, this is the cleanest one. There's not a lot of pollutants, like I said, nitrogen, sulfur, because these are relatively small molecules. There's not a lot of room to carry the nitrogen and the sulfur in them. Some disadvantages is when you're transporting it as liquefied natural gas, you're losing some of that energy returned on energy invested because you're spending a lot of energy keeping it cold and pressurized on that fuel truck. It's also more difficult and more costly to transport natural gas a long distance because it's so spread out. The density is very low here because it's in gas form, and so you can't get as much of it into a container as you could something like coal or something like oil. It's also possible to extract methane from ice. So in the Arctic, as the climate gets warmer and you're getting permafrost melting, we've discovered that methane is being released, especially deep under the ocean up in the Arctic as well. And so this is a very abundant source of it. but it's very hard to extract because it's so remote and it's so spread out and not very concentrated. And essentially, as this stuff warms up, the frozen ground, it releases it. And so the downside for global warming is methane is a greenhouse gas. And so the more methane you release, the warmer the climate gets. The warmer the climate gets, the more permafrost melts, and the more methane it releases. And so it's kind of this positive feedback loop from it. But it would be great if we could figure out a way to harvest and collect this methane so we could at least use it for something like running a car or heating a house or cooking with before it got released out into the atmosphere. And that's where I'll stop for this video. So thank you for watching the video on natural gas and shale and sand oil.